Hey everyone, and welcome back to the Deep Dives. You know how we love to get into the nitty-gritty of space exploration.
Yeah.
Well, buckle up, because today we're diving into the world of asteroid mining. But not the exciting Hollywood stuff. We're talking about the unexpected enemy.
The silent killer?
You got it.
Space dust.
Dust!
Really? Oh, yeah. It's a much bigger deal than most people think. If we're serious about mining those asteroids, dust is the first hurdle we need to clear.
See, this is why I love having you here. You always bring the knowledge. So I found this article called Dust Mitigation and Containment Strategies in Asteroid Mining. And it's wild.
It's like a good one, right?
Yeah. It starts by describing this dust, and it's not just floating dirt out there.
No, not at all. It's a fascinating mix of stuff. You've got your silicates, metals, even organic materials.
Wait, so some of this dust is valuable itself?
Exactly. So right away, you have to think about how to extract the valuable stuff from the not so valuable and how to even figure out what's what.
Okay, my mind is blown. And the article says this dust ranges in size from nanoparticles all the way up to gravel.
Yeah, it's a huge range. It's a nightmare for engineers trying to design equipment to handle all that.
I can imagine. Plus, it's not like dust on Earth.
No.
This stuff is electrically charged because of all the solar wind and cosmic radiation.
Right. It's constantly being bombarded.
Okay, now that's where I need some help.
Oh, yeah.
Electrically charged dust. What does that actually mean?
Well, think about it. On Earth, dust settles because of gravity. But in space, it just floats around.
Everywhere.
Everywhere. And because it's charged, it clings to everything. Tools, machinery, even other dust particles.
Ooh, so it's not just floating, it's like magnetic.
Pretty much.
Oh.
Imagine trying to work in that environment.
Sounds like a total nightmare.
Ew.
And this article doesn't sugarcoat the dangers.
Nope.
It goes into detail about how this dust can really mess things up.
It's a serious problem. You've got these tiny abrasive particles that can wear down your machinery, clog up sensitive parts,
And
contaminate instruments.
it's got to be expensive.
Oh, yeah.
Yeah.
We're talking about multi-million-dollar equipment out there.
And then there's the human side of things.
Right.
The article mentions health risks for anyone working out there.
Of course, breathing in those fine particles, especially with unknown toxicity, that's a major concern. So we need to think about spacesuits and habitats that are dust-proof, not just airtight.
Dust tight, too. Yeah. Okay, so we've got this incredibly hostile environment for humans and machines. But surely brilliant minds are working on solutions.
Absolutely. There are some really innovative approaches in development.
Could tell me more. The article mentions something called electrodynamic dust shields. It sounds like something straight out of Star Trek.
It kind of is. The idea is to create electric fields that repel dust particles before they can settle. Basically an invisible shield.
That's so cool, using the dust's own charge against it.
Exactly. But they're also looking at more familiar solutions.
Oh, like what?
Things like vibration systems to shake off dust, and magnetic deflectors to pull away metal particles.
Clever. So they're adapting what we know from Earth and making it work in space.
Right. Exactly. It's all about taking inspiration and applying it to a new environment.
It makes you wonder, though, if we're going to all this trouble to manage dust in space, could we apply those lessons back here on Earth?
Now, that's an interesting thought. Could we use those same techniques to control pollution or clean up hazardous environments?
Yeah, exactly.
It's definitely something to think about.
See, this is why I love this show. We start with asteroid mining, and we end up talking about cleaning up our planet.
It's all connected.
Well said.
Yeah.
All right, so we've established that space dust is a major problem, and that there are some really creative solutions in the works. But this is just the tip of the iceberg.
Yeah, we've only just scratched the surface.
All right, so last time we left off realizing just how much of a pain space dust is for asteroid mining.
Yeah, it's not going to be easy.
So let's get into the nitty-gritty. How does this dust actually affect the whole process of mining an asteroid?
Well, the article breaks it down into stages, and dust is a challenge at every single one.
Okay, so walk me through it, starting with the first step, excavation.
Right, so you're trying to dig or drill or scoop up material on an asteroid, and you're going to kick up a massive dust cloud, especially with that low gravity.
I'll be like
Trying to dig a hole on the beach on a windy day.
but worse?
Way worse. There's no air to slow the dust down.
Okay, so how do they deal with that?
The article talks about these special drills. They have integrated dust collectors.
So they're vacuuming up the dust as they're creating it.
Pretty much. It's like a shop vac, but way more high-tech.
Clever. Okay, so you've dug up the material. Now what?
Now you got to move it, which is another huge challenge.
Yeah, all those conveyor belts and hoppers.
Exactly. All those transfer points where dust can escape.
Or just cling to everything.
Right. So containment is key. They're designing these enclosed transport systems, almost like sealed tubes.
Makes sense. You don't want to lose those precious resources.
And you definitely don't want a dust storm inside your mining operation.
True. Okay, so you've excavated the material, you've moved it, now you have to process it.
And guess what? More dust.
Really? I figured that part would be dust-free.
Nope. When you're breaking down the ore and separating out the valuable stuff, it creates even more dust.
Oof. So what's the solution there?
More containment. They're using things like magnetic and electrostatic separators, but the key is to keep everything sealed up tight.
So it's like a giant zero-gravity dust-busting operation.
That's a great way to put it.
It makes you appreciate just how complex this all is.
And remember, this is all happening millions of miles away from Earth.
Like, where repairs aren't exactly easy.
So the equipment has to be incredibly reliable.
Makes sense. Okay, so they're developing all these solutions, but how do they know they'll actually work?
Testing. The article mentions some really interesting case studies.
Oh yeah, like what?
Well, there's NASA's work on the electrodynamic dust shield.
That's the one that sounds like Star Trek, right?
Nope, it's super cool. They basically create these electric fields that act like an invisible barrier,
Yeah.
repelling dust particles.
So like a force field.
Pretty much.
Yeah.
And they've already tested it successfully on lunar regolith.
Wait, so we're learning from the moon and applying those lessons to asteroids.
Exactly. It's all about building on what we know.
I love that. And what about that Japanese mission? Hayabusa 2. I remember that one. They collected samples from an asteroid.
Right, Ryugu. They had this clever trick to minimize dust during the collection process.
What did they do?
They used a small projectile to create a mini crater.
Ah, so they basically controlled the dust cloud.
Exactly.
Very clever.
Okay, and of course we can't talk about space dust without mentioning the Apollo missions.
Oh yeah, those astronauts were covered in this stuff.
It seems like every mission adds to our toolkit for dealing with this problem.
Absolutely.
Mm-hmm.
And that brings us to the exciting part.
Okay, hit me with it. What's on the horizon for dust mitigation?
Well, the article talks about some truly cutting-edge ideas.
Like what?
They're exploring self-cleaning surfaces that repel dust.
Wow.
And even nanotechnology that could manipulate dust at the molecular level.
Nanobots cleaning up space dust. That's amazing.
Right, but what about the dust that's already there? Yeah, they can't just vacuum the entire surface of an asteroid.
Well, that's where things get really interesting. They're looking into in situ dust management.
Okay, break that down for me.
It means actually modifying the regolith itself.
So instead of cleaning up the dust, they're preventing it from forming in the first place.
Exactly. And of course, no discussion of the future would be complete without mentioning robots.
Oh, of course.
They're already developing autonomous dust clearing systems.
Robot dustbusters. I love it.
It's pretty cool. So we've got self-cleaning surfaces, nanobots, regolith modification, robot dustbusters.
It sounds like we're well on our way to conquering this dust dilemma.
We're getting there. But the article mentions one more concept that I find really intriguing.
Okay, I'm all ears. What is it?
Integrated space infrastructure.
Now that sounds like something straight out of a sci-fi novel.
It kind of is. Imagine centralized dust management systems shared by multiple missions or facilities.
So like a giant space-based dust control network.
Exactly. A collaborative effort to keep space clean.
It's amazing how far our thinking has come since those early Apollo missions.
It really is. But let's be realistic. There are still a lot of challenges ahead.
True. But if we've learned anything from this deep dive, it's that human ingenuity is more than capable of tackling those challenges.
Wouldn't agree more.
All right, so we've gone from the hazards of space dust to the incredible solutions, and even a glimpse into the future of dust mitigation. But there's one final piece of this puzzle we wanted to explore. You know, it's funny, we started this whole deep dive thinking about the excitement of asteroid mining.
Spaceships and lasers.
Exactly. And somehow we've ended up fascinated by dust.
It's true. But it just goes to show that even the smallest things can have huge implications.
Especially when we're talking about venturing into the unknown.
Right. It's like this tiny little annoyance, this dust, is forcing us to come up with some truly incredible solutions.
And not just for space either.
That's the really exciting part.
So we've talked a lot about adapting solutions from Earth for space. But what if it worked the other way around?
I see where you're going with this. What if those solutions we develop for space dust could actually be applied to problems here on Earth?
Exactly. I mean, we're putting all this time and energy into managing dust in space. Could we take those lessons and apply them to things like pollution control or hazardous environments?
It's definitely a possibility. Think about all the industries that deal with dust here on Earth.
Construction, mining, agriculture.
Exactly. And then you've got things like air pollution and maybe even cleaning up microplastics in the ocean.
It's mind-blowing to think that the solutions to some of our biggest challenges here on Earth might be floating out there among the stars.
And that's the beauty of space exploration. It often leads to unexpected breakthroughs that benefit us in ways we never imagined.
Well said. So as we wrap up this deep dive into the world of asteroid dust, we want to leave you with a final thought to ponder.
A little something to spark your own deep dive.
What if the key to a cleaner, healthier planet is hidden in the dust of a distant asteroid? Just something to think about. And that's it for this episode of The Deep Dive. We hope you enjoyed exploring the fascinating world of space dust with us. Until next time, keep looking up and keep asking questions.